Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Keam Prep, we are going to be looking at previous year questions asked in Keam 2020. So Keam is an examination that helps attendees enter the engineering, architectural, and medical services in the state of Kerala. So in order to prepare for such an exam, the best thing to do is to look at previous year questions of the same exam. So today we're going to be looking at previous year questions of various subjects asked in Keam. First, let's look at physics. Here's a question from Keam 2020 for physics. A solid sphere of radius r is revolving around one of its diameters with an angular velocity of omega. If it suddenly expands uniformly so that its radius increases to n times its original value, then its angular velocity becomes n square omega, omega by n square, n omega, omega by n to n omega. So, which of these is the correct option? Now, originally, the radius of the sphere r1 was equal to r. The angular velocity omega 1 was equal to omega. And after expansion, r2, the radius, will be equal to n times r, and omega 2 is what we have to calculate. Now, since we are, since the same sphere is being expanded, the expanded sphere will have same mass. Now, it suddenly expands uniformly, so this force that the expansion force is internal. So there is no external torque acting on the sphere. Torque means the couple or moment of force. So what we're going to do is we're going to use the conservation of angular momentum. Basically, that means initial angular momentum is equal to final angular momentum. So therefore, that means I1 times omega 1 equals I2 times omega 2. Now, the moment of inertia of a solid sphere is 2 by 5 times mr squared. And since the sphere is having the same mass, the mass stays the same. So when we apply the formula for moment of inertia of a solid sphere in the equation, you'll get 2 by 5 times m times r1 squared, r squared, times omega 1, which is omega, as equal to 2 by 5 m times nr the whole squared times omega 2. So 2 by 5 and m gets cancelled. So you get omega r square as equal to n square r square omega 2. So we can cancel out r square here. Now let's take omega 2 on one side. The other side will be omega divided by n square. So the angular velocity of the sphere after expanded to n times the original radius is omega divided by n square. So among the following options, it is clear that option B is the correct option. Now let's look at another question. If a ring rolls down from top to bottom on an inclined plane, it takes time t1 if it slides, and it takes time t2 to roll. Then the ratio t1 square by t2 square is. Alright, so in this particular question, T1 is the time taken to roll, and T2 is the time taken to slide. So therefore, the ratio here is T2 squared divided by T1 squared. Now, let's draw the ring on an inclined plane. So in the sliding example, the ring weighs mg, and when we break it to its components, it'll be mg cos theta and mg sine theta. So during sliding, the total force that's acting on the ring is mg sine theta. So using the second law of using Newton's second law, we can write F equals ma. So mg sine theta equals ma. Cancel out m. You get a equals g sine theta. Now, that we know that a equals g sine theta, we use the second law of motion. So only using the second law of motion, which is S equals ut plus half AD squared. So we're talking about uniform motion, so kinematics. Now, the distance here is L, that is the length of the inclined plane. And then since u equals 0 because it starts from rest, so ut will be 0 plus half into g sine theta times t2 squared. The reason why it's t2 squared, if it slides, it takes time t2. So now that we know L equals half g sine theta t2 squared, we can write t2 squared as equal to 2 times L divided by g sine theta. So that is the value of t2 squared. Now let's find out the value of t1 squared. So for that, we have to consider pure rolling. So during pure rolling, the ring is undergoing translational as well as rotational motion. So we have mg and then mg cos theta, and then you have mg sine theta. But since this is rotational motion, we also have, the ring, it also contains rotational motion. We also have the ring moving under an angular acceleration alpha. And since it's pure rolling, at the point where the ring touches the plane, there is a friction F, which, makes that point stationary. So the point that's touching the plane is not moving, because if it did move, then that would be more sliding. Here we're undergoing pure rolling, so therefore it's both rotational and translational. Perfect rolling. Now, translation-wise, that means the motion we've done so far. The net force here will be mg sine theta minus F equals m times a. So how do we find out the value of this F? That's where we use rotation. So when we consider rotation, we will use the formula for torque, tau. Now tau is I times alpha, so this is considering Newton's second law. Now Newton's second law actually states that force equals mass times acceleration. The rotational equivalent of force is torque. The rotational equivalent of mass is moment of inertia, and the rotational equivalent of acceleration is angular acceleration, which is alpha. So during rolling, the linear acceleration can be written as r times alpha. Now, we also know that torque is the moment of force, which means it's R cross F, which is RF. So RF is equal to I times alpha. Now I times alpha can be written as I times A by R. Now the moment of inertia for a ring rolling in an axis passing through center of mass is equal to mr squared. So I will be now equal to mr squared, and then alpha is A by R, R times F on the left. So R cancels out one R, and the other R gets cancelled by the R on the left. So therefore, the frictional force is equal to M times A. So now plug this value of F in the earlier equation. So that is mg sine theta minus ma equals ma. So therefore, mg sine theta will be ma plus ma, that is 2 times ma. So m gets cancelled out here. So therefore, a equals g sine theta divided by 2. So that is the value of the linear acceleration for pure rolling. And now we use the second law of kinematics. So s equals ut plus half ad squared. So here s is still the same inclined plane, so L. So it's again from rest, so ut is 0 plus half times the acceleration, which is g sine theta by 2, times t1 squared. So therefore, it'll be g sine theta divided by 4 times t1 squared. Therefore, t1 squared will be equal to 4L divided by g sine theta. So now that we know the values of t2 squared and t1 squared, let's divide both the values. So t2 squared by t1 squared is equal to 2L divided by g sine theta, the whole divided by 4L divided by g sine theta. So L gets cancelled, g sine theta gets cancelled. You finally have 2 by 4, which is equal to 1 divided by 2. So therefore, the correct answer to this question is option D, 1 divided by 2. So the ratio t2 squared by t1 squared is equal to 1 by 2. And in order to find out the time, the square of time, we have to use the motion of a ring along an inclined plane. So one was when it slides completely, and another was when it was under pure rolling. In the sliding case, all we have to do was use, equations from the laws of motion. But for the second case, we had to use, system of particles and rotational motion. Now let's look at some questions of chemistry. CH4 plus 4Cl2 gives you CCl4 plus 4HCl, which escapes as a gas. Now, in the above reaction, the change of oxidation state of carbon is. Well, how do we find that out? CH4 is represented as CHHH. Now, hydrogen wants to donate its electron, so it always takes a +1 charge. So when you are attached to 4 hydrogens and all of these hydrogens have a +1 charge, the carbon has to have a charge of -4. On the contrary, when you have carbon surrounded by halogens, for example chlorine in CCl4, so halogens always have -1 most of the time, so therefore -1, -1, -1, -1. So they're resting, oxidation state is -1. So then since you have -4 outside the carbon must have a charge of +4 in order to make this 0, because for stable compounds the total oxidation state has to be 0. So as you can see from CH4, which had an for carbon had an oxidation state of -4, we have moved on to CCl4, where carbon had an oxidation state of +4. So therefore, option C from -4 to +4 is the correct answer. Option A is incorrect because for that you have to start from CCl4 and then move towards CH4. And +1 to +4 is incorrect because the charge is incorrect. Again, option D, again, the charge is incorrect. And option E also has incorrect charge. So option C is the correct option for this question. Next question. A solution is prepared by dissolving 20 grams of NaOH in 1250 ml of a solvent of density 0.8 grams per milliliter. Then the molality of the solution is 0.2 moles per kg, 0.08 moles per kg, 0.25 moles per kg, 0.0064 moles per kg, 0.5 moles per kg. So, how do we solve this question? Well, this question is comparatively easy. What we have is comparatively, long. So what we have to do is find out the mass of the solution first. We know that the solution has a volume. Actually we need to find the mass of the solution here. So the solution is basically 20 grams of NaOH dissolved in 1250 ml of a solvent. So the mass of the solution will be equal to volume of the solution times density. And now we know both volume and density here. So we just have to plug in those values. 1250 times 0.8, which basically is 1250 times 8 by 10. So 0 gets cancelled. It's 125 times 8. So 5 times 8 is 40. 8 times 2 is 16, plus 2 is 20. And 1 times 8 is 8. 8 plus 2 is 10. So we totally get a value of 1,000 grams as the mass of the solution. Now that we know the mass of the solution, let's find out the mass of the solvent, since we're finding out molality. The mass of the solvent. So the mass of the solvent will be equal to mass of the solution minus mass of the solute. So that is 1,000 grams minus 20 grams, which will give you 980 grams of solvent. So the mass of the solvent that we have in 1250 ml of the solvent is 980 grams. Next, we need to find molality. Molality is represented by the formula number of moles of solute divided by the mass of the solvent in kg. So number of moles can be calculated as given mass by molar mass. So here the given mass is 20 grams divided by the molar mass of NaOH. So that's 23 plus 16 plus 1. So 23 plus 1 is 24, plus 16 is 40. So 20 divided by 40, the whole divided by mass of the solvent, which is 980 grams per thousand, since we have to represent this in kilograms. So we are going to represent this fraction as 20 times 1,000 divided by 40 times 980. So 0 cancels out, 0 cancels out, and 2 goes into 4 twice, and then you have 2 going into 150 times, and then 50 divided by 2 is 25, 98 divided by 2 is 49. So therefore the molality here is 25 divided by 49, 25 divided by 49. So you have 0, because 49 doesn't go into 25, so and when you put a point, you get a 0 here. So 49 must go into 250. So for that, you'll need to multiply 49 times 5, because 40 times 5 is 200. So 9 times 5 is 45. 4 times 5 is 20. 20 plus 4 is 24. So 245 is what we get. So we put 5 in here. 5 times 49 is 245. The resultant is 5. Then you can put in a 0. You get 1 minus 49. So that's 1. And then you can put a 0, but still it doesn't satisfy. Put another 0. You get 100. So then you get 2 times, and then that's 98, which is 2. Now you can go on and on, dividing this, but let's stop here and put in an approximate value. So the molality of the solution that we have is 0.5102 moles per kg, and we can approximate that as equal to 0.5 moles per kg. So if you look at the following options, you can see that option E, 0.5 moles per kg, happens to be the correct answer. So what we did was we first found the mass of the solution, then we subtracted the mass of the solute in order to get the mass of the solvent, and then we used the formula for molality, which is number of moles of solute divided by mass of the solvent in kg, and by using calculation and by calculating all the values, putting in all the values and then dividing the whole thing, you get 0.5 moles per kg as an approximate value for the molality of the solution. Now let's look at some questions of mathematics. In a group of 100 people, 80 people can speak Malayalam and 60 can speak English. The number of people who speak English only is? Well, in this group, we will consider that all of the 100 people speak one or the other language. So, we will consider N of A as the number of people who speak Malayalam, which is 80, N of B as the number of people who speak English, that's total, so 60, and since there are a total of 100 people, we can consider N of A union B as equal to 100. So first we need to find out the number of people who speak both languages, and to find that, it's quite easy. N of A union B can be written as N of A plus N of B minus N of A intersection B. So we're using set theory here. N of A union B is 100. N of A plus N of B, so that's 80 plus 60 minus N of A intersection B. So 80 plus 60 is 140 minus N of A intersection B. So therefore, N of A intersection B is equal to 140 minus 100, which is equal to 40. So now we know that N of A intersection B is 40. We know that the number of people who can speak both languages are 40. Here we need to find out the number of people who speak English only. So that means we need to subtract the number of people who can speak both languages from the number of people who can speak English. Basically, we need to find out the value of N of B minus A, which is N of B minus N of A intersection B. So that is 60 minus 40, which is equal to 20. So 20 people in a group of 100 people can speak English only. So therefore, the correct answer here is option C, 20. Option A is incorrect because that refers to the total number of people who speak both languages. 30 is incorrect because when we subtracted 40 from 60, we got 20. So options D and E are also incorrect because that results in incorrect subtraction. So therefore, option C, 20, is the correct option. Now let's look at the final question of this episode. If star is a binary operation defined by A star B as A by B plus B by A plus 1 by AB for positive integers A and B, then 2 star 5 is equal to. So 2 star 5. 2 is A, 5 is B. So therefore you get 2 by 5 plus 5 by 2 plus 1 by 2 into 5. So this is the correct, equation. This is the equation that we need to get by, replacing A with 2 and B with 5. So now we will get 2 by 5 plus 5 by 2 plus 1 by 10 as the sum of the fractions here. So since 10 is the LCM around here, let's take 10 as the LCM. So 5 times 2 is 10, so 2 times 2 is 4. 2 times 5 is 10, so 5 times 5 is 25, and plus 1. So 4 plus 1 is 5, 5 plus 25 is 30. 30 divided by 10 is the value of 2 star 5. So the value of 2 star 5 is equal to 3. So therefore option B, 3, happens to be the correct option for this question. All we have to do was to, put in the values of A and B as 2 and 5 and do that binary operation. Then we had to, take the LCM and then get the answer. So all of these are just basic arithmetic operations. So therefore option B is the correct option for this question, which was asked in 2020. Now that concludes the end of, so that is the end of this episode on Keam Prep. We hope you found this episode interesting. For more of our videos on Keam Prep, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of content uploaded on Brain Blitz Audio, so if you want to get updated about our latest content, then don't forget to hit the bell icon that's below the video. Also, if you want to get the playlist regarding Keam and its assorted matter, then please hit the playlists link, which is present in the description box down below. So until the next webisode, take care, stay safe, bye bye for now.